So last we left off, we found that this thing right here, the limit as h approached 0, right, became just this function here, n times x to the n minus 1. All the other terms that had an h left over in it after we canceled the h out got erased because h went close to 0. So all these basically became 0. The only thing we were left with was this guy. If you kind of can understand that pattern, then the same thing is going to happen whether it's x plus h to the n or x plus h to the n minus 1 minus x to the n minus 1 over h. The limit as this h approaches 0. So the only thing that's going to leave us with is, well, the original term was x to the n minus 1, so it would be n minus 1 times x to the n minus 2. And that would be the only thing we're left with. Now, it won't matter if there's a constant in front. If there's a constant in front, all these would have a constant, right? Whatever the constant was, it doesn't matter. But they'd still go to 0. So this one would be the only one left with this constant, so that was its original constant, the first constant. Okay? And this one would have had the second constant. Okay, so the second constant times n minus 1, x to the n minus 2. Just for exercise, for practice, I recommend you try that out and see that that's the same. I guess intuitively one way you can think about it is that in any given power, whether it's x plus h to the n or x plus h to the n minus 1, the first term gets canceled out right here. He's going to cancel out the first term, right? The x to the n minus 1. So the only thing left is going to be the second term, x to the n minus 2, right? The x to the n minus 2 is going to be what's left. All the h's are going to cancel out everything past it. This guy gets canceled out, so that's the only guy that's left, right? And his coefficient would be n minus 1 choose 1, which of course is n minus 1. And of course he has his original constant in front, which is this C2. Okay, so for any given power, for any given expansion, the second one is the only thing that gets left when you take the limit as h approaches 0 of this guy right here. So how is that meaningful? Well, what we really want more than anything else is the limit as h approaches 0 of, what was it? F of x plus h minus f of x divided by h, right? And if we take each individual term, what will that become? Okay, so it will be C1, C2. I'm going to write out the constants because I don't feel like changing colors. Cn minus 1 and Cn. Now, what are my x's? This was n times x to the n minus 1. This was n minus 1 times x to the n minus 2. Let me clean this up a bit, and notice how whatever constant number I have here, so this is C1, x is raised to n minus that constant power. So I have C2, x to the n minus 2, okay? So if I have C, let's take on C to, do that yellow, keep it constant, C n minus 2, I'm going to have that multiplied by something, right, times x to the n minus 2, which is basically x squared. And this n is 1 bigger than whatever the exponent is. So this is a 3. And then for the next term, I'll have plus Cn minus 1 times 2x to the first plus my final Cn term. And all of that equals the derivative of any function, which also can be written as f prime of the function.